Ubiquitous computing is a concept in software engineering and computer science where computing is made to appear everywhere and anywhere. In contrast to desktop computing, ubiquitous computing can occur using any device, in any location, and in any format. A user interacts with the computer, which can exist in many different forms, including laptop computers, tablets and terminals in everyday objects such as a fridge or a pair of glasses. The underlying technologies to support ubiquitous computing include Internet, advanced middleware, operating system, mobile code, sensors, microprocessors, new I/O and user interfaces, networks, mobile protocols, location and positioning and new materials. This new paradigm is also described as pervasive computing, ambient intelligence, or everywhere. Each term emphasizes slightly different aspects. When primarily concerning the objects involved, it is also known as physical computing, the Internet of Things, haptic computing, and things that think. Rather than propose a single definition for ubiquitous computing and for these related terms, a taxonomy of properties for ubiquitous computing has been proposed, from which different kinds or flavors of ubiquitous systems and applications can be described. Ubiquitous computing touches on a wide range of research topics, including distributed computing, mobile computing, location computing, mobile networking, context-aware computing, sensor networks, human-computer interaction, and artificial intelligence. Core concepts: at their core, all models of ubiquitous computing share a vision of small, inexpensive, robust networked processing devices, distributed at all scales throughout everyday life and generally tend to distinctly commonplace ends. For example, a domestic ubiquitous computing environment might interconnect lighting and environmental controls with personal biometric monitors woven into clothing so that illumination and heating conditions in a room might be modulated, continuously and imperceptibly. Another common scenario posits refrigerators aware of their suitably tagged contents, able to both plan a variety of menus from the food actually on hand, and warn users of stale or spoiled food. Ubiquitous computing presents challenges across computer science, in systems design and engineering, in systems modeling, and in user interface design. Contemporary human-computer interaction models, whether command-line, menu-driven, or GUI-based, are inappropriate and inadequate to the ubiquitous case. This suggests that the natural interaction paradigm appropriate to a fully robust ubiquitous computing has yet to emerge, although there is also recognition in the field that in many ways we are already living in a ubiquitous world. Contemporary devices that lend some support to this latter idea include mobile phones, digital audio players, radio frequency identification tags, GPS, and interactive whiteboards. Mark Weiser proposed 3 basic forms for ubiquitous system devices, see also smart device, tabs, pads and boards. Tabs, wearable centimeter-sized devices, pads, handheld decimeter-sized devices, boards, meter-sized interactive display devices. These 3 forms proposed by Weiser are characterized by being macro-sized, having a planar form and on incorporating visual output displays. If we relax each of these 3 characteristics, we can expand this range into a much more diverse and potentially more useful range of ubiquitous computing devices. Hence, 3 additional forms for ubiquitous systems have been proposed. Dust miniaturized devices can be without visual output displays, for example microelectromechanical systems, ranging from nanometers through micrometers to millimeters. See also smart dust. Skin, fabrics based upon light-emitting and conductive polymers, organic computer devices, can be formed into more flexible non-planar display surfaces and products such as clothes and curtains, OLED display. MEMS device can also be painted onto various surfaces so that a variety of physical world structures can act as networked surfaces of MEMS. Clay, ensembles of MEMS can be formed into arbitrary 3-dimensional shapes as artifacts resembling many different kinds of physical object. In his book The Rise of the Network Society, Manuel Castells suggests that there is an ongoing shift from already decentralized, standalone microcomputers and mainframes towards entirely pervasive computing. In his model of a pervasive computing system, Castells uses the example of the Internet as the start of a pervasive computing system. The logical progression from that paradigm is a system where that networking logic becomes applicable in every realm of daily activity, in every location and every context. Castells envisages a system where billions of miniature, ubiquitous intercommunication devices will be spread worldwide, like pigment in the wall paint. Ubiquitous computing may be seen to consist of many layers, each with their own roles, which together form a single system. Layer 1, Task Management Layer, monitors user task, context and index, map user's task to need for the services in the environment, to manage complex dependencies. Layer 2, Environment Management Layer, to monitor a resource and its capabilities, to map service need, user-level states of specific capabilities. Layer 3, Environment Layer, to monitor a relevant resource, to manage reliability of the resources. History. Mark Weiser coined the phrase ubiquitous computing around 1988, during his tenure as chief technologist of the Xerox Palo Alto Research Center. Both alone and with PARC director and chief scientist John Seeley Brown, Weiser wrote some of the earliest papers on the subject, largely defining it and sketching out its major concerns. Recognizing that the extension of processing power into everyday scenarios would necessitate understandings of social, cultural and psychological phenomena beyond its proper ambit, Weiser was influenced by many fields outside computer science, including philosophy, phenomenology, anthropology, psychology, postmodernism, sociology of science and feminist criticism. He was explicit about the humanistic origins of the invisible ideal in postmodernist thought, referencing as well the ironically dystopian Philip K. Dick novel Ubiquitous. Andy Hopper from Cambridge University UK proposed and demonstrated the concept of teleporting where applications follow the user wherever he/she moves. Roy Want, while a researcher and student working under Andy Hopper at Cambridge University, worked on the Active Badge System, which is an advanced location computing system where personal mobility that is merged with computing. Bill Shillett also did some earlier work in this topic, and participated in the early mobile computing workshop held in Santa Cruz in 1996. Dr. Ken Sakamura of the University of Tokyo, Japan leads the Ubiquitous Networking Laboratory, Tokyo as well as the T-Engine Forum. The joint goal of Sakamura's Ubiquitous Networking Specification and the T-Engine Forum, is to enable any everyday device to broadcast and receive information. MIT has also contributed significant research in this field, notably Things That Think Consortium at the Media Lab and the CSAIL effort known as Project Oxygen. Other major contributors include University of Washington's Ubiquomp Lab, Georgia Tech's College of Computing, Cornell University's People Aware Computing Lab, NYU's Interactive Telecommunications Program, UC Irvine's Department of Informatics, Microsoft Research, Intel Research and Equator, Adja University Akron and CUS. Examples: one of the earliest ubiquitous systems was artist Natalie Jeremijenko's LiveWire, also known as Dangling String, installed at Xerox PARC during Mark Weiser's time there. This was a piece of string attached to a stepper motor and controlled by a LAN connection. Network activity caused the string to twitch, yielding a peripherally noticeable indication of traffic. Weiser called this an example of calm technology. Ambient devices as produced an orb, a dashboard, and a weather beacon. These decorative devices receive data from a wireless network and report current events, such as stock prices and the weather, like the Nabazda produced by Violet Snowden. The Australian futurist Mark Pess has produced a highly configurable 52 LED lamp-enabled lamp which uses Wi-Fi named Moore's Cloud after Moore's Law. The Unified Computer Intelligence Corporation has launched a device called UP, the ubiquitous computer that is designed to allow voice interaction with the home and provide constant access to information. See also, List of ubiquitous computing research centers, augmented reality, ambient intelligence, context-aware pervasive systems, human-centered computing, human-computer interaction, natural user interface, pervasive game, pervasive informatics, physical computing, virtual reality, sensor grid, sentient computing, smart device, task computing, transreality gaming, ubiquitous commerce, ubiquitous learning, virtual reality, wearable computer. References. Resources and other external links. An introduction to the field appropriate for general audiences is Adam Greenfield's book Everywhere, The Dawning Age of Ubiquitous Computing. Greenfield describes the interaction paradigm of ubiquitous computing as information processing dissolving in behavior. Conferences in the field include, International Conference on Pervasive Computing, ACM International Conference on Ubiquitous Computing, IEEE International Conference on Pervasive Computing and Communications, IEEE International Conference on Pervasive Services, IEEE GlobeCom Workshop on Service Discovery and Composition in Ubiquitous and Pervasive Environments, the Second International Conference on Mobile Ubiquitous Computing, Systems, Services and Technologies, academic journals and magazines devoted primarily to pervasive computing, Personal and Ubiquitous Computing, Pervasive and Mobile Computing Journal, PMC, Ubiquitous Computing and Communication Journal, UBICC Journal, Mark Weiser's original material dating from his tenure at Xerox PARC, Ubiquitous Computing, other links, context and adaptivity in pervasive computing environments, links with software engineering and ontological engineering, article in Journal of Software, Vol 4, No. 9, 992-1013, November 2009 by Ahmet Soylu, Patrick de Korsmaker and Payet Desmet, Yesterday are Euro unregistered trademark S tomorrow's, Notes on Ubiquitous Computing Euro unregistered trademark S Dominant Vision, by Genevieve Bell and Paul Dowrish. Towards Pervasive Computing in Healthcare a Euro a Literature Review, article in BMC Medical Informatics and Decision Making by Carson Orvat, Andreas Graef and Tim Follwasser. Pervasive Technology Lab Pervasive technology to help people with mental health problems. Ubiquitous computing is a concept in software engineering and computer science where computing is made to appear everywhere and anywhere. In contrast to desktop computing, ubiquitous computing can occur using any device, in any location, and in any format. A user interacts with the computer, which can exist in many different forms, including laptop computers, tablets and terminals. For ubiquitous computing has been proposed, from which different kinds or flavors of ubiquitous systems and applications can be described. Ubiquitous computing touches on a wide range of research topics, including distributed computing, mobile computing, location computing, mobile networking, context-aware computing, sensor networks, human-computer interaction, pervasive computing, ambient intelligence, or everywhere. Each term emphasizes slightly different aspects. When primarily concerning the objects involved, it is also known as physical computing, the Internet of Things, haptic computing, and things that think. Rather than propose a single definition for ubiquitous computing and for these related terms, a taxonomy of property and artificial intelligence. Core concepts. At their core, all models of ubiquitous computing share a vision of small, inexpensive, robust networked processing devices, distributed at all scales throughout everyday life and generally tend to distinctly commonplace ends. For example, a domestic ubiquitous computing environment might interconnect lighting and environmental controls in everyday objects such as a fridge or a pair of glasses. The underlying technologies to support ubiquitous computing include Internet, advanced middleware, operating system, mobile code, sensors, microprocessors, new I/O and user interfaces, networks, mobile protocols, location and positioning and new materials. This new paradigm is also described as